Okay, so we're gonna get the second problem in your assignment. It's still consumer choice theory. The first video explained the basics of consumer choice. I've explained to you how to draw budget constraint in different curves, get the optimal combination, get the substitution effect, as well as the income effect. Once you know that, which is a very basic, get the two axes. We always work in two dimension. One will be your consumption, the other one will be leisure. Draw your budget constraint based on getting the extreme on each side. How much consumption do I have if I have zero leisure? How much leisure do I have if I have zero consumption? Put in your indifference curves, you get the optimal point. Then you can start playing around. You can increase your wage. By increasing wage, your budget constraint pivot going up. Remember, the pivot means your leisure point remains always the same. It stays where it is. Okay, so your indifference curves, this is your budget constraint. That's your leisure, that's your consumption. The budget constraint will be like this. Pivot means it can go down when your wage goes down. It can go up when your wage goes up, and vice versa. Okay. So in this example, Ben sleep 8 hours a day and therefore have a remaining 16 hours to share between leisure and labor. So here we purposely exclude sleep time. So sleep time doesn't count. You literally have a day of 16 hours that you can use between leisure, and here leisure excludes sleeping. So sleeping is not considered as leisure. So you have 16 hours a day. You can decide how many hours you want to work. Some people work 8 hours, some other 10, some other 12. So he decided to work 8 hours a day, and it's a week of 5 days. So at the end of the total week, it's 40 hours. But 16 times 5, it's 80 hours. So we now work for a total week. So if the total week is 16 hours, that's all you have. Remember, we exclude sleeping time. 16 times 5 is 80. So 80 will be the total number of leisure time if you work 0 hours. But you see here, Ben's constraint, his income is $10. So what do we get here? I'll show you just with 1 point, or maybe 2. I'm not going to solve the assignment. So this is 80 hours. But he works for $10 per hour. And let's say, how do I get this point here? It's if leisure is 0. So if the whole 80 hours, here leisure 0, total 80 hours, 16 times 5, if all the 80 hours are used for labor, let's say he works 16 hours non-stop, okay? How much money is he gonna make? 16 times 10, no, 80 times 10, it's 16 times 5, that's 80, 80 times 10, that's $800. So you have $800 tied to 80. That's supposed to be straight. So it's $800 tied to 80. That's your budget constraint. Get your budget constraint. And then we start playing around. They say what? Oh, well, your wage goes up to $14. Okay, I'm not going to solve that for you. You will be able to find it. When wage goes up, then it's going to go up there, somewhere like this. So your graph goes up. And how do you get that point? Just take 14 times 80. And then it goes up again to 18 hours, $18 per hour. That'll be up again like that. And here what they say is assuming that you draw an indifference curves. Your indifference curve such that Ben's labor supply is upward sloping when the wage is 10 to 14. Now that's the interesting part that I want to show. So I'm going to have two graphs here. One will be the consumer choice optimal graph. So this one here And then I have another graph here that will represent your labor supply. Let me see. We'll try and get it more streamlined. Okay, so we can get it half. So that's first half, that's another half. So this goes up like this, and this goes up like this. Okay, so that's my first graph with consumer. So that's my consumption, and that's my leisure. And here it's my labor supply. Just simple labor supply. It's a labor supply curve. And how do you draw a labor supply curve? You have your wage, like your price. Price is always vertical axis. And on the horizontal axis will be the quantity of labor, okay? QOL, the number of labor hours worked. So here we want the labor supply to be upward sloping. You draw in the indifference curves is upward sloping when the wage is 10 to 14. So this is when the wage is 10. You have 80 hours, you have 800. Then the wage goes up to 14. So you go up here. Your indifference curves go. So we had an indifference curves here, okay? And that's where I was. That was my number of hours. And that's the number of labor, that's the consumption. Now it goes up. When it goes up, one thing happened. This is the new budget constraint. The new budget constraint is here. And the new indifference curves is there. So the new optimum point will be here. As you can see, the number of labor hours increase, leisure decrease. And consumption, of course, will decrease over here. Okay, so the number of labor hours, well, not necessarily. Your consumption can increase as well. So if I have this one here, right up here, okay, your consumption can be up here, yes, and your leisure is right here. So you have an increase in your level of consumption, and you have an increase in your number of hours worked because your income goes up. Remember, income goes up. So the indifference curves, I put the indifference curves in such a way that it's on your budget constraint, and it's at such a point where it's higher for the consumption and it's higher for the labor. Okay, so that's new indifference curves. And so this is your new level of consumption from here. It's an increase. And that is your new level of labor from here. It's an increase, and leisure goes down. Okay, so because number of labor goes up from here to here, when we represent it on the labor supply curve, what happened? Because there is an increase in wage, we do have an increase in labor. So your labor supply curve is an upward sloping curve. Why? Because there is a positive effect here. Your wage increases the number of hours worked. Wage increase labor supply. As the graph shows, that's what it says. Show that the graph allows your labor to move from here to there. All you have to do, draw a budget constraint, put an indifference curve such that it gives you a higher level of consumption and a higher level of labor. Simple. The other part, now when your income goes up again from 14 to 18, from here going up to 18, instead of doing what we did right here, I could have done it. I could have put it in indifference curves that touch here, so I have more labor and more leisure. Here, the difference is I now said it's a backward sloping when the wage is between 14 and 18. So purposely, when wage goes up now from 14 to 18, this is when wage was 14. This is when it was 10. It's now backward, which means that there is no increase in the number of labor, but a decrease in the number of labor. So your new indifference curves will not be here, but your new indifference curves will be somewhere here. So your indifference curves will be there. You're going to touch it like that, and that's where you are, right here. So when you get down, your labor will be less than what it was at 14, decrease. Your consumption will still go up, but your labor will go down. So when you represent it here, it's now interesting because what happened to the labor supply curve, it will be interesting because from 10 to 14, we were going up. We were going up. You see 14, 10 to 14 was going up. But when I go up to 18, okay, it's now not going up anymore. It becomes backward bending. So your labor supply curve is not up anymore, but it turned around here. That's what we call the backward bending labor supply curve. Okay, so at a certain level, when your income start increasing at past a certain threshold, your incentive to work decreases. And that is a rich people effect. There is a certain level where you work for money and you have bills to pay and you have one paycheck to the other paycheck and you have to do it every day. And the more you work, the more you can afford, the more you can pay your bills, the more you can do. That's just normal, and therefore you have to work more. The more you work, the happier you are. But there's a certain level where they start paying you very good money. For example, you earn $20 per hour. Your incentive will be more, go more to work to get more. But if you reach a point where you start earning $1,000 per hour or $200,000, it's like Michael Jordan, I heard he was offered $100 million for a 2 hours, a 2 hours event, and he canceled. When you are at that level, and he's a billionaire, it's the incentive to go work is no longer as much as it was when you were only $20. At that time, they enjoy their leisure time much more. So a very rich person, even if you offer him that much money, $1,000 for an hour, he would rather go, in his yacht on the Lake Michigan, or, go in his golf resort, spend the weekend. Okay, so that type of person, for that type of income, the labor supply is no longer straight up, but it's a backward bending labor supply. So it's going to go up and then turn down over here, because now it's become negative. Start having a negative impact. It's no longer straight, it's now negative. It's a downward sloping. You see, this was upward sloping, and that's downward sloping. It's turned at a certain level. At this level, it becomes downward sloping instead of upward sloping. Okay, so that was the example. I gave you a lot of information for this question. When it comes to the question on perfect competition, it's very easy. I gave you a tutorial, actually a list of revision questions on perfect competition that you can use. It's been posted on your Blackboard. You can use that pretty easily. Okay, so pretty much here, you have a cost function, which is provided here, plus q squared plus 2q. And then I give you a demand function, P equal to 1200 minus 2q, and a supply function, P is 120 plus q. How do you get the equilibrium? You just equal the supply and the demand. You equal these two equations, and you find what is q. And once you find what is q, you find what is p. And once you have what is p, what is the equilibrium quantity? That's q. What is the equilibrium price? That is p. And then on b, I give you the marginal cost. Okay, marginal cost, you get it by getting the first derivative of your total cost. And I already gave that. So marginal cost is 2q plus 2. Then you have the optimizing condition for perfect competition. Marginal cost equal marginal revenue equal price equal average revenue. Use that equation to solve anything else here.